Today I'll be making another video on Applied Mathematics for Engineers course. Today we're going to discuss the problem of Cauchy's integral theorem, but I'm not going to go way too detailed about where the theorem comes from. You can look it up in other videos like from Khan Academy and other tutoring videos. I personally haven't made that explanation yet, but today I'm going to explain some basics about it and how we're going to apply the formula, the main formula of the Cauchy's integral theorem, to help us solve complicated integrals into simple evaluations of that complicated integral. So let's jump into it. Cauchy's integral theorem. So the main formula of this Cauchy's integral theorem is, suppose we have an closed integral of path c of a function of fc divided by z minus z naught, where z naught is the point enclosed in the path c with respect to dz. And we're going to transform this form into this form, which makes life more easier. So you might be pretty wondering about how we're going to use it. Let's just jump into one problem. Suppose we have an integral, closed integral over the path c, where 3z to the power of 3 minus 8 over 2z minus I with respect to z. So we have this messy integral over here, and we could use these substitution integrals and those kinds of sophisticated techniques, but it requires a much amount of time to evaluate the complicated integral. Instead, by using Cauchy's integral theorem, we could transfer this part over here. We could transfer it into this form and make it into this form over here. So what we're going to do is, first we're going to match these two forms. We're going to make this form into this form, as we see that the coefficient of z over here is equal to 1, and in the problem we have the coefficient of z is equal to 2, so the coefficients don't match. So what we want to do is we're going to multiply the numerator and the denominator by half, just simply to get rid of that 2. So rewriting things, we're going to have 3 over 2 of z to the power of 3 minus 4 divided by z minus a half I with respect to z. As you see over here, we already have this first form over here. So the next step is we're going to transfer this form over here into this form and calculate it. So let's use a different color. So this part, whoops, it hasn't changed. So this part over here is FC, and this part over here, whoops, this part over here is C naught. So writing things again, this equals to 2 pi I times FC. FC is 3 over 2 z to the power of 3 minus 4, where z is equal to z naught, which is equal to a half of I. So we're going to input this half of I into this C over here. So let's clear things up. Before I clear this, you could copy the pink part over here. Writing things again, we had 2 pi I times 3 over 2 z to the power of 3 minus 4, where z is equal to half I. So we're gonna put those numbers in. So this equals to 2 pi I times 3 over 2 times a half of I to the power of 3 minus 4. So we're going to solve the numbers in the bracket. We're going to have 2 pi I times 3 over 2 times 1 over 8 times minus 1, since I squared is equal to minus 1, with I, because it is I to the power of 3, minus 4. So rearrange things up, and we have 2 pi I times minus 3 over 16 I minus 4. So we're going to multiply this with this and this with this, which then equals to 3 pi over 8 minus 8 pi I, which then equal to 3 pi minus 64 pi I. So see if you have the same answer with me, or if I've done some mistakes in the calculations. I pretty much did in a hurry. Please do correct me in the comment box below, and hope this gives you an enlightenment of how we're going to use Cauchy's integral formula in solving complicated integrals, and hopefully I could make some more examples on the applications of this. So don't forget to like the video and subscribe to my YouTube channel for more future videos, and hope to see you soon. Bye.